Okay, so in the second talk in this group, we're going to talk about relations, delimiters, and spacing. All right, so let's share the screen. Back to it. Relations. LaTeX knows how to typeset extra space around relations. Things like equals, backslash, approx. These should always all have a little bit of space around them. LaTeX knows that and does it for you. So you don't have to worry about it other than do not muck it up. So the other sort of relations are inequalities, less than, greater than, less than or equal to, greater than or equal to, and the very much so. So the backslash LL, the backslash GG gives the double less than sign and the double greater than sign. Also there's the set relations, in and subset, and a whole host of other relations. So, for example, which I want to mention particularly, is these very much so relations. Do use them where appropriate, because you get a beautiful result like this using this code, right? Naught is less than epsilon backslash LL1. Commonly what people do, very common error, is they typeset the double less than sign like this, and that's just wrong, and it's ugly. Not only is it wrong, it's also ugly. And we can see that in the maths. Where's it gone? Relations. Yeah. Well, instead of getting this nice, beautiful result here, typesets like that. Just don't do it. Okay, so what's next? Delimiters. Delimiters are things which delimit parts of an expression. So, as you can read, parentheses, brackets, braces, angle brackets. There's also vertical bars, vertical double bars, which are typeset with backslash vertical bar. Many people fall into the error of typesetting vertical double bars by just putting two bars. That's not correct. You go backslash vertical bar. Now, the thing about delimiters is, angle brackets are backslash left angle, L angle, and wrangle. Do not use the greater than and less than relations for this purpose, because LaTeX knows that they are relations. And relations are quite distinct from angle brackets, from delimiters. They're treated differently. Right? Delimiters don't necessarily have space around them, and they come in various sizes. The relations have space, and they're the one size. So, especially for the physicists there, we are generally the ones who use angle brackets, physicists and the mathematicians. Langle and wrangle. Okay, various sizes. There's several ways to get various sizes. The simplest way to get the size of them nearly correct is to use the modifying commands backslash left and backslash right. So you go backslash left delimiter, and then LaTeX searches through looking for its matching backslash right and some delimiter. The delimiters don't have to be the same, but the left and right have to occur in pairs. When LaTeX looks at what's in the middle, typesets it, find out what height it has, and then typesets the delimiters to suit that height. It's not perfect, but it does a pretty good job. So here are some examples. You can backslash left, parenthesis A plus B, backslash right, parenthesis. You just get an ordinary size parentheses. However, if there's a fraction like that, those fractions are generally large, so backslash left bracket, backslash right bracket, they'll be large brackets. as you can see in tech. Where is it gone? Here it is. There are large brackets. And in the source, this is what I've been describing just there. So this command applies to all of the delimiters. So the vertical bars, here we've got square root of mod xy, is less than or equal to mod of the arithmetic mean of x and y. And these need to be large, and we just get them suitably large by \left, vertical bar, \right, vertical bar. And you can use left and right, even if there's no matching delimiter, as in this version of integration by parts. Integrate this by parts and you get u div dx evaluated between a and b. And that's quite a common symbol. How do you get that big when there's no left for it to match? And the answer is you use \left dot. It doesn't typeset a dot. The dot is just a placeholder saying this is the left that matches this right. So the other place that you might need to use a \left dot or a \right dot is where you split a long expression over two lines. If the expression has a delimiter at the start and at the end, the left and the right have to be on the same line. And when you split the line, they're not. So a simple rule, which doesn't always work, but mostly does, is in the first line you have \left, whatever, left parenthesis. And then at the line break, you go right dot. And then at the start of the next line, you go left dot. And then the right, end of parenthesis. I'll show you an example of how to do that later. That brings us to spacing. There's a lot of subtleties in spacing, so let's introduce it. So why does it bring it to spacing? So you see in these examples on delimiters, I separated the punctuation from the mathematical expression a little bit here. And I did here as well. And this is good practice. When the punctuation may get confused with the mathematics or hidden in the mathematics, just separate it by a small space. And the thin space is \comma. You don't always need it, so you have to be the one deciding. So following a delimiter, you generally don't need a thin space. So there is not one. Okay, so there's lots of spacing commands. How to keep it simple for you? Well, the simple reason is just use two in maths. \comma typesets a thin space. \quad typesets a quad space, which is the width, which is 1m wide, the width of a capital M. So where do you use these characters? Well, thin space to separate punctuation from mathematics where necessary, but also in the infinitesimals in an integrand. So for example, down here, I've got a double integral, xy squared dx dy. Notice there is a thin space between the dx and the dy, and a thin space between the integrand and the dx. This is high quality typesetting. And there's the source with the thin spaces in them. Learn to do that. Didn't need to put a thin space at the end of this equation because the superscript 3 naturally puts enough space to separate the comma from the expression. Okay, so that's... Oh, and where else do you need a thin space? When you're separating physical units, abbreviated physical units, from a number. So if you want gravity is 9.8 meters per second squared. You separate meters per second squared from the 9.8 by a thin space. If the physical units are not abbreviated, you use a full space, which you can get from either a non-breaking, best is a non-breaking space. Remember the two that I've already introduced you to? Okay, so where do you use a quad space? Most commonly to separate two or more equations on the one line. That's its role, main role. So here is, a vector identity really. So component u of the vector is minus y over x squared plus y squared. Component v is x over x squared plus y squared, and w is 0. So those three equations need to be separated by a quad space. And the and is separated by a quad space. So here you can see it. There's the first quad space after that. Then to put an English word into the mathematics, use \text from A&S Math, where else? Or even to put several words, \text. All right, and then another quad space before the W is 0. Double integrals, going back to the integral note, I used \iint. That's another one from A&S Math. It typesets a double integral sign properly. There's also the \iint for a triple integral. Use them. Now, one of the common errors is with punctuation. I don't know, people get a bit funny about punctuation. What you have to remember is the display or not of mathematics is irrelevant. You must punctuate a sentence with mathematics in it, whether that mathematics is displayed or in line. And so you have to punctuate it as if the mathematical statements are an integral part of the sentence. Okay, so it's just as if you had made an English statement there. It's a statement punctuated accordingly as you would. Now, one thing to note is if the mathematics is displayed in line, put the actual punctuation outside the mathematics environment so that LaTeX knows what to do, but that is indeed a punctuation symbol, full stop at the end of a sentence or a comma, because LaTeX is more flexible about spacing after a full stop or a comma, but it only would do that if the full stop, comma is outside the maths. Now, another issue is the odious proliferation of bad colons. I don't know where this comes from. It's all over the place, and you must learn to avoid doing this. Otherwise, I will come and haunt you, I promise. So, one example is this sort of statement. People write, Newton's second law is, a colon, F is equal to MA. Do not do this sort of thing. There is a fundamental rule for colons in English, and that is the two parts of the sentence on either side of that colon must make complete statements in their own right. So if you go into this sentence, F is equal to MA. That is a statement in its own right. So that's fine. There are scenarios where you could put it after a colon. Newton's second law is. That is not a complete sentence. So that cannot be on the one side of a colon. So you've got to make sure that that part is also a complete sentence. There's two ways. The simplest way is just don't have the colon. Perfectly good sentence. Newton's second law is F equals MA. Nice, short, crisp. Sometimes in more complicated statements, you might want to say Newton's second law is the following, colon, F is equal to MA. that would be all right because Newton's second law is the following, is a complete statement. It's just two verbose, so you don't want to do it. But it's valid. Right, what else have I got? One last thing. Occasionally we get very bad line breaks with inline mathematics. So if you've got mostly where you've got a list of things, of comma-separated maths, might be a list of symbols, whatever. Might be a vector components, might be a list of the first 12 primes, such as these. There's a big chance that a list like that will need line breaking. Because those commas are inside the maths environment, LaTeX doesn't want to line break them, and so it generally doesn't. So you can override LaTeX distaste of putting line breaks for those commas by this mysterious magical recipe. You include into that maths environment this command, and it tells LaTeX that the commas in there are commas that you can put a line break in. But do that discerningly. It also puts a little bit more space around the commas, which often is a good thing when you've got a long list. Okay, so that's about relations, delimiters, and subtleties of spacing.